Okay, so let's go over the homework assignment and then cover a few things, and then I'll give you another assignment. So let's look at what was the homework. So last time we talked about, we continued to talk about functions, and we focused on whether a function returns a value or not. Remember, functions are reusable chunks of code. We write it once, it performs some task. Sometimes it gives us an answer back. Sometimes it might just display something to the screen. Sometimes it just does something, doesn't display it, doesn't hand it back, but maybe it's updating a database somewhere else in the cloud or whatever, if we're starting to talk about some more complex programs. But functions are something that we want to have happen more than one time, that we can call upon, giving it some different inputs, and then either trusting that it did what it was supposed to do, or getting some sort of output, whether it's printing to the screen or returning a value. The thing we were focusing on here is whether a function returns a value or doesn't return a value. That dictates what how we write the function. In terms of the syntax for a function, the very first thing we need to do is we need to talk about the return type. So here's our syntax for functions. Notice we have the return type. What kind of value is this function returning? With the emphasis there being on the word return. If our function does something and then hands us the value back to use for something else, we would have a return type there being whatever kind of value that is. If our function is not going to return a value, instead it's going to do something, it could display something, and that's the kind of the main thing here I want to really drive home, is that displaying something to the screen is different than returning a value from a function. All right, so if we are not returning a value, the return type would then be void. And we're going to see that when we do the solution to the homework here in a minute. Okay, so let's look at our, well, let me just review one other thing. So that's what we talked about last time. We also then talked about the return statement, or the return keyword. The return keyword does two separate things. The first thing that return does is it makes a function immediately end. In the monopoly term, do not pass, click go, do not collect $200. All right, it makes the function immediately end. Then optionally, it can also send a value out of the function to be used somewhere else. All right, this implies that you can actually use the return keyword in functions that have a return type of void. You can't use the return keyword in conjunction with a value that you want to return, because you've advertised to C++ that you're not going to return a value, since you've set the return type as void. But if for some reason in the middle of your function you have a if statement or something that if it's true, you want to make the function immediately end, you can do that with the return statement, and make the function immediately end. Just kill it, don't go through loops anymore, whatever. Okay, so let's look at the homework assignment. Oh, it's pretty small font there. All right, so I gave you kind of a starting point, but I think I'll probably just gut what I have. So we're doing a couple of different things. So I give you two different functions to write here, and one of them is an example of a function that returns a value, and then another one is a function that doesn't return a value. So the first one, write a function called find largest. That's going to take two integers as parameters, and it's going to return the larger of the two integers. If the integers are the same, it doesn't matter which one you return. Okay, then I gave you some examples of, if you called the function on the number 17 and 91, it would return a 91. If you called it on 8 and 2, it would return an 8. So it's always returning the larger of the two values. All right, and then this last one, if it's you passed it a 41 and a 41, it's going to return a 41. It doesn't matter which of the two 41s it returned. All right, so let's go ahead and write that one first. So it's called find largest. I'm just going to copy that so I don't have to spell it right. And I'm going to go ahead and I'm just going to delete everything from my program so you can see the process here. I'll go ahead and just leave myself with main. And I like to always just test my program. We'll just do a little hello world thing here, make sure my program is functioning and I have a working development environment. So I'll go ahead and hit run. There's my hello world. So I know that my clean slate here is a good starting point. All right. So now I'm going to go ahead and as my pattern has been, I've been implementing my functions after main and prototyping them before main. All right, so we're going to have a function called find largest that's going to take in two numbers and return an integer. So it's going to take in two integers and return the larger of the two integers. All right, now I'm going to implement it after main here, but I'm going to prototype it before main here. And just as a reminder, the reason why we prototype is in the event that you have multiple functions that rely on each other, they wouldn't call each other until you actually implement them later on. So we effectively are just creating a list of all the functions that will exist before main, because at that point they don't rely on each other because we don't have the implementation inside of the functions. And then we actually implement them later once the compiler knows about all of the existence of all of them. So it knows that one function might call another one and it knows about both of them. All right, so in find largest, we're just following our usual couple of patterns. We're going to ask a question. If num1 is greater than num2, then we're going to go ahead and we're going to return num1. Remember, the purpose of this function is to return the larger of the two values. All right. Now I'm going to do a couple of things inside this function just to drive home the point of a couple of things we just talked about. I'm not even going to put an else. I'm going to just put, let me put a couple of enters after that so we can bump it up on the screen. All right, so find largest is its name. It's going to take in two integers. I've named them num1 and num2 as parameters. I'm going to ask a question. Is num1 larger than num2? If it is, I'm going to return num1. Now notice I have not put an else here afterwards or anything. I've just put another return statement, return num2. Okay, now it's not incorrect if I want to put an else in there. If you want to really be verbose about this, you can say, else if num2 is greater than num1, then you can return num2. Else you can go ahead and return num1 or something, because at that point there must be the same, so it doesn't matter which of them we return. All right, so you can be very verbose where you're saying if number 1 is greater than number 2, return number 1. Else, if number 2 is greater than number 1, return number 2. Else, they must be the same, so you can return num1. Similarly, you could also return num2 because they're the same. All right, so that's asking a lot of questions, but which is accurate. There's nothing wrong with that. But I'm going to go ahead and I'll even remind you on this one. We have 3 different return statements in my code here. All right. Remember that return makes a function immediately end. All right. Immediately. That means that if I hit this return statement right here, I won't go any further in my program. This function will end. All right. I won't go any further in this function. Program might not be over yet, depending on who called this function, but this function will immediately die. Okay, so keep that in mind, that part of the tool of return is functions immediately end when you hit a return statement. Optionally, you can return a value with a return statement. In this case, I have advertised that I will be returning an integer. Therefore, when I have my return statement, I will pick the integer that I will be sending back out. Okay. So let me go back to this implementation, which I would call a fairly optimal implementation to this assignment, although it does rely on you having your mind wrapped around this idea that a return statement makes a function immediately end. All right, so again, we take in two integers. We ask, is the first integer larger than the second integer? If it is, we will return the first integer. Again, return makes this function immediately end. So we will not get to line 25. It will stop right there. Okay? Which means that if this is false, if num1 is not larger than num2, which means num1 is, well, that means num2 is at least as big as num1. So they're either the same value or num2 is the larger value. I don't have an else or anything. I've just thrown this thing in here and return num2. The only way I'm even still alive in this function is if I failed this question, failed this Boolean expression. Remember, a Boolean expression is any expression that boils down to a single value of true or false. All right, so the only way I even get to line 26 here is if line 22 boiled down to false. Okay, so when I get to line 26, logically, I know that either num2, well, I know that num2 is not smaller than num1. It's either the same or it's larger. And since it doesn't matter which of the two we return when they're the same, I'm going to just go ahead and say return num2. It's either equal to num1, in which case it didn't matter which of the two I returned, or it must be the larger of the two values, in which case I want to return num2. So my code right here situationally returns num1 only in the case where num1 is larger than num2. Otherwise, it's going to go ahead and just return num2. But I do not need it inside of an else, because the only way I'm even still alive in this function at line 26 is if line 22 resulted as a false, which means I never got to line 24, which means this function is still going. So when I get to line 26 here, now this function immediately ends, because return makes a function immediately end, and I'm returning the value num2. Okay. So there's our find largest. I gave you a couple of examples to test this with, 17 and 91. So let's go ahead and we'll do a cout find largest 1791. So I'm calling my function here. My function returns a value. So after I call it, this guy is going to boil down to the value that it was returned. What am I doing with that value? I'm just printing it. I'm not storing it anywhere. I could. I'll store the next one and show you, but we get to decide what we want to do with the value that's returned by that function. So the first one, I'm just letting the value come back and I'm immediately printing it. The second one, I'll go ahead and say int answer is equal to find largest. And what was the example I told you to use? 8 and 2. So I'll pass that same function the values 8 and 2. And then I'll go ahead and do a cout on answer. All right. And then lastly, we'll keep reminding ourselves of some of these different rules, since I've already defined a variable named answer. So I gave it its type, and here's answer. I brought it into existence. I used it on this line right here. Then I printed out the value. I can now reuse that variable. I don't define it again because it's already defined in the current scope. But now I can go ahead and use it. I'm going to use it to call find largest again, passing it 41 and 41 by the example I gave in the homework assignment. And then I'll go ahead and print out the new value stored inside of answer. All right. So first call to the function, I call it with 17 and 91, expecting to get a 91 out of it, and I'm just directly printing that 91. My second call to the function, I'm passing in an 8 and a 2, expecting it to boil down to an 8. What am I doing with that 8? I'm capturing it inside of this variable. I'm remembering that. So I bring into existence a variable named answer of type integer. I'm storing the result of find largest here, which I expect to be an 8. So after this line, answer will hold an 8. What will I do with it? I'm going to print 8 out to the screen, print the current value of answer out to the screen, which I expect to be 8. And then on line 22 here, I'm going to reuse that variable because I've already remembered it before. I've already used the value. So now I can reuse that variable to remember something else, but I don't need to redefine it. I'm just going to reuse it. All right. That's why I have not put an int in front of it again. It would be incorrect for me to redefine it. It's going to say, hey, there's already a variable in this scope named answer. What are you doing? But I'm allowed to reuse that variable and remember something else in it if I want. So I'm going to call find largest again, passing it a 41 and a 41. I expect the result to be a 41 because neither of them are actually larger than the other one. So it didn't matter which of the two I returned, but I'm going to capture what I expect to be a 41 inside of answer, and then I'll print that out. So we expect the output of this program to be 91, then 8, then 41. So we'll go ahead and run that guy. There's our 91, our 8, and our 41. Okay, now if we were sitting in class right now, I'd ask, are there any questions? Feel free to email me or Slack me any questions since we're not live right now. Remember, I am back on the 15th, so I will see you in class next week, but I am around. I have internet connectivity and everything, so I'm happy to answer any of these questions, but I'm trying to be as verbose as I can in these explanations. So, really try to listen to all the things I'm saying because I'm reiterating things I've previously said. And I'm also showing you various approaches to doing the same thing in this code here. Okay. So that's find largest or a version of find largest. If you got the same results, writing yours a little bit differently, as I kind of mentioned before, this might be somewhat uncomfortable for some of you because it really relies on you understanding that the return keyword makes a function immediately end. So the only way we're even still alive here on line 34 is if this code did not happen, which means this did not execute, did not boil down to true. All right, so we're kind of relying on this little, you can almost think of it like a trap, I don't know, or I guess what they call the mortar things. You might step on the thing and the trap goes off, whatever it is. But in any case, the only way you get to line 34 is if none of this stuff occurred. All right. But for some of you, if you want to be really very meticulous about the way you write this, you might just ask your answer, ask your questions very verbosely, where you say, if num1 is greater than num2, do this. If num2 is greater than num1, do something else. We'll return number 2. Else, they must be equal to each other. Put a little comment here. They must be equal to each other. So it doesn't matter which we return. Remember, this is a comment and we put the // in front of it. So I'll just go ahead and return number 2. If you like to write num1 instead of num2, you can, because it doesn't matter which of the two. All right, so we've written many more lines of code here, but it's equivalent code. So if I run this, you're going to see we get the same answers. Nope. What did I forget to do? 30. Oh, because I have the else if. This is else if. I kind of sort of took a shortcut there. I'll show you what I mean by that in a second here. So there's your same answers, the 91, 8, and 41. All right. So technically, I took a little shortcut here because in class, when we looked at if statements, I said you should always use opening and closing curly braces. It's never wrong to use the opening and closing curly braces. Well, technically here, I have an else followed by another if. So what I really should have here is this else. What I'm about to write here is identical to what I just had, but I purposely left out some curly braces on the previous one because it's pretty commonplace to do that. So I'm going to have my if, then I'm going to have my else, where we're always going to have the curly braces, even though they're not required if you only have a single statement, which is why it worked in the previous example. So now I'll go ahead and inside that else, I'm going to ask a new question. If num2 is greater than num1, return num2. Else, we finally got to the point where we can return num2. So this question, if else, exists entirely inside of the second else, which only occurs if we fail here. This is identical to what I had written just a second ago. Okay, the difference here is that I put in the opening and closing curly brace for this else here, rather than omit the opening and closing curly brace for that else, and instead have a single statement inside the else. Even though it's a lot of lines of code, technically that is a single if statement. Okay, so it only counts as one statement. All right, again, you can choose which of those you like better. Pretty common practice to write it like this, where if you're doing an else if, you don't use the curly braces for that else, that first else there, because you are having a single statement after it. But it does go against what I said in class, where I said you should always use the opening and closing curly braces, and it's never wrong to use the opening and closing curly braces. Therefore, following that tactic to the T, your code should look like that if you always use the curly braces. Okay, but I promise you the logic for all of those is the identical logic. It just looks a little bit more verbose with all the opening and closing curly braces, but hopefully you see how indenting is also important here, where you can clearly see this if else structure lives inside entirely of this else structure, which is the alternative to this if structure right here. The alternative being that if this is true, do this. Otherwise, the alternative is ask the second question. Okay. So that's the first function to write, and that's an example of a function that you give it some parameters and it does something and returns the answer, returns it. We then got to choose what we wanted to do with the value that was returned. I guess in all of the cases here, we chose to print out the answer, but I could have just as easily decided here to say int val is equal to that. So I'll create a new variable called val, set it equal to whatever comes out of find largest 17 and 91, which we expect to be a 91. But when I run this program right now, we'll see we never see the 91. We just see the 8 and the 41. Why? Because I only printed out the 8 and the 41. I called find largest 3 separate times, but the very first time that I called it, I remembered my answer here inside of a variable called value, or variable called val, but I never actually did anything with it. Later on, I could print out val, and we'll see the 19 now is, or 91 now is last. All right, But I could also do something with that value. I could do something like val is equal to val divided by 2 or something like that. And now we would get the integer division of 91 divided by 2, which should be 45. So that's me getting the result from a function and then doing something with that result. In this case, just randomly, I'm dividing it by 2, and then I'm outputting it. Okay, so lots of different approaches there, but really trying to drive the point home of a function that takes in inputs and does something and then returns that value for the programmer to decide what they want to use that value for. All right, second function is write a function called make change that takes an integer as a parameter representing a number of pennies and displays to the screen the best way to represent those pennies using dollars, quarters, dimes, nickels, and pennies. All right, so we're going to go ahead and it's going to be called make change. I'm going to steal that guy here. And it's going to display something to the screen. It is not going to return a value. All right, so it's called make change. It's going to take in a number of pennies and it is not going to return a value. Instead, I'm just going to do all the logic inside of there and display a bunch of stuff to the screen. All right. So now what we want to do is we want to go ahead and we want to show the number of dollars first. Then we want to show the number of quarters, then dimes, then nickels, and ultimately the number of pennies we have left over. And in order to solve this problem, we're going to be using some of the tools we've already learned, like the modulus operator. All right, so we're going to start off by saying dollars. And we can store this in multiple variables as well if we wanted to, but I'm just going to do it this way. So I'm going to say dollars is equal to whatever the current value of pennies is divided by 100. All right. I'm not changing the value of pennies yet. I'm just saying whatever the current value of pennies is, let's divide it by 100 and let's get the answer. So for example, I gave if it was 136, 136 pennies divided by 100, 100 goes into 136 one time. That's going to be 1. Then I'm going to update pennies to be equal to whatever it currently is mod 100. So if in the example pennies started off as 136, 136 divided by 100 is 1. 136 mod 100 gives you 36, the leftover amount. Okay, so we're going to steal those couple of lines here. So now we're going to say quarters. And this is going to be however many pennies are left over after we modded it here. We're going to divide that by 25. That'll give us quarters. Then we'll find out how many pennies are left over after we've done the quarters. Similarly, dimes. This is divided by 10. And then how many are left over after I mod it by 10? Nickels. Divided by 5. How many are left over after I mod it by 5? And finally, pennies. We're just going to output current number of pennies. And I forgot to kick it down a line on each of these, so I'll just steal that from up there. Tack on the \n on every one of those lines. All right, so make change will take in a total number of pennies and print out the number of pennies divided by 100, then adjust the number of pennies. The number of pennies left over divided by 25, then adjust the number of pennies. Notice we are changing the value of pennies here. Do the same thing for dimes, nickels, and finally, we're going to output however many pennies we have left over after doing all of that. Okay. So now up here in main, I'm going to go ahead and I'm going to call make change on 136, which was from our example here. So if I passed in 136, I should get $1, 1 quarter, 1 dime, 0 nickels, 1 penny. So there's my $1, 1 quarter, 1 dime, 0 nickels, 1 penny. All right, if I want to change it to 12,136 pennies, we're going to get a lot more. So we get $121, 1 quarter, 1 dime, 0 nickels, and 1 penny left over from that. Notice I can call this guy multiple times. So I'll just put some random numbers in there, and we'll see we get 3 different outputs for those things. There's our dollars. There's the first one. Then here's our second one. And finally, here's our third one. Why? Because I called my function 3 times. I did not use the value that came out of this function. Why? Because that function does not return a value. I said its return type is void, will not return a value. All right, and what did I do inside here? I chose to display stuff to the screen, not return a value. Okay, so there is some examples of, well, those are 2 functions there and some examples of how it works. So if you struggled with this, I'd encourage you to go through this video, kind of type it out, make any typos you might make, get past that idea of it's like, oh, well, I typed exactly what you typed and it gives me an error. Trust me, you didn't type exactly what I typed. You typed something very similar, but not exactly. You're probably missing a semicolon or a space, or you capitalize something you weren't supposed to capitalize, or you're missing a curly brace, you know, or you've put your functions inside of main, that kind of thing. So there are differences in your code from my code. It's I promise you, it's never going to be the case that the compiler is just not working right on your machine, and that's why you're getting errors. You caused the errors, I promise you. Okay, so that is the solution to that. So now what I'm going to do, as we are getting more and more advanced with our programming, is I am going to introduce, we're going to go back to our number conversion stuff, and I'm going to introduce how to convert a number from decimal into any other base. Okay. And then what we're going to do is we are going to write the functions for converting to binary, octal, and well, we'll do decimal as well. You'll see from this example. And then we'll leave it at that. And then in the next assignment, I'll have you do one little step above that. Hopefully you're going to see the pattern here. So we'll do it in 2 separate assignments, but the assignment I'll give you today, in fact, we'll go ahead and write the assignment first. That way, as we're doing the solution here, you can think about it. So your homework is write 3 functions. One function will be called decimal to binary. Another one is decimal to octal. Another one is decimal to decimal, which you might think is stupid, but it'll make sense here in a second when I show you these examples. Decimal to binary should take an integer as a parameter and display to the screen one number per line. And you'll see what I mean by that. Since I haven't shown you the ability to do that differently yet, we're going to stay consistent with how we've been doing stuff. The equivalent number in binary, I'm going to say in reverse. Put a little note up here. The reason the answers are all in reverse is because that is how the math works. And I have not shown you the tool you will need to reverse the final answer. We'll introduce that next class. All right. And that note will make sense here when I go through it here in a second. All right. So I'm just going to fill in the gap for all these other ones. So to octal, should take an integer as a parameter, display the screen, one number per line, the equivalent number in octal. Again, in reverse. And then to decimal, should take an integer as a parameter and display to the screen one number per line, the equivalent number in decimal. I'm actually going to add a little bit here. Should take an integer as a parameter. I'm going to put in parentheses, representing a decimal number. That's what that integer input is representing, is a decimal number. All right. So now let's talk about how the conversion works, and I'll explain what some of my statements in here mean. They'll make more sense once you see it. All right. So decimal to binary. Let's just come up with a sample number. So I'm going to say the number 19. Decimal to binary. So I mentioned when we were first looking at converting values between bases, I mentioned that we have two patterns. We have one pattern that goes from decimal to any base, and then we have another pattern that goes from any base back to decimal. All right. The pattern we're looking at for this assignment is the one that is decimal to any other base. But we're actually not going to go to any other base. We're only going to convert to binary, octal, and decimal. And if you want to translate that, what I'm really saying is we're only going to convert to bases that don't require letters, that don't get into the A's through F's that we have for hexadecimal. That's a feature we will tack on in the next assignment. Okay, well, we'll talk about it in class next time. All right, so 19 decimal to binary. The pattern that we use for this is, since we're going to binary, remember binary is base 2. We're going to take our 19, we're going to divide it by 2. All right, 19 divided by 2 is a 9. 9 times 2 is 18 with a remainder of 1. Takes one more to get us to 19. 9 times 2 is 18. Takes one extra to get us to 19. So now we go from that 9. We divide that by 2. 9 divided by 2 is 4. 4 times 2 is 8. Takes one extra to get us to 9. So we're recording the remainders over here. Remember, we have the modulus operator for getting the remainders of things. So this is really just a problem of integer division and getting the modulus. All right. Then we have 4 divided by 2, which is 2. 2 times 2 is 4, with nothing left over. Then we have 2 divided by 2. 2 goes into 2 one time. 1 times 2 is 2, with nothing left over. Then we have 1 divided by 2. How many times does 2 go into 1? 0 times. 0 times 2 is 0, with 1 left over to get us to 1. Okay, now this is our stopping case here. We keep doing the same pattern. We're going to keep dividing our number by 2, recording the integer division answer, quotient, and recording our remainder, displaying our remainder to the screen. All right. We're going to keep doing that until we finally get a quotient of a 0. That's our stopping case. So all this is probably going to go inside of a loop. Keep doing this pattern of dividing by 2 and recording the remainder, displaying the remainder to the screen over and over and over again until we get a quotient of 0. All right. Now, the way we would read this conversion, and this is where that part comes in where I say display it in reverse. Because if you're thinking about this as our program that you just wrote, you've already displayed this 1, you've already displayed this 1, you've already displayed this 0, you've already displayed this 0, you've already displayed this 1. So they're already on the screen. But the reality is you've actually displayed the answer in reverse, because the way we read this is from the bottom up. Number 19 from decimal to binary is 10011. We read it from bottom up. So this is the actual converted answer, but I haven't shown you how to reverse stuff yet, or how do we store stuff in another format so that we can reverse it. So this is your expected output from the program. I expect your program for this particular one to output the number 1 on a line, followed by the number 1 on the next line, followed by the number 0 on the next line, the number 0 on the next line, the number 1 on the next line. That's your full output for that program. All right. Because when we finally get our answer, we would read it from the bottom up and then get a real final answer, which is what you've already displayed backwards. But I'm not going to have you do that for this assignment, since I'm not going to introduce the tools you need for doing that. If you want to challenge yourself and go and figure out how to do that, you can, but that's not what I'm expecting you to do. I'm expecting you to do some division and some modulus stuff, like we've done inside of a while loop, to keep doing it until your quotient is 0. We're practicing with loops here. Okay, so that's an example of decimal to binary. I'm going to steal this exact same slide, and we're going to go decimal to octal. This guy's base 8. So let's assume we were doing that same value, 19, from decimal to octal. Instead of dividing by 2, we're going to divide by 8. How many times does 8 go into 19? It goes in 2 times. 2 times 8 is 16, with a remainder of 3. Remember, with octal, our legal octets are 0 through 7. 0 to the base minus 1. So then we have 2. 2 divided by 8. How many times does 8 go into 2? 0 times. 0 times 8 is 0, with 2 left over. We see our stopping case here is 0. So we read our answer from bottom up. So that's 2, 3. But as I said before, you've already outputted the 3, you've already outputted the 2, so you've actually displayed the correct answer in reverse, which is acceptable for this assignment. Okay, but notice we followed the identical pattern. We took our decimal value and we kept dividing by, in this case, 8, since we're converting it to octal, over and over and over again, recording the remainder and remembering the quotient. So we're using integer division and modulus, exact same things we've been using on previous assignments, but we're doing this inside of a loop now, and we're going to keep going as long as the quotient is not a 0. All right, so for these assignments, you're not having to do this part here. You've actually displayed the 3 to the screen, then you displayed the 2 to the screen. So you put the answer out there in reverse. Okay, so notice we have the same pattern here again. So really, once you solve one of these functions, you've actually pretty much solved all 3. All you're changing is the division thing. And that's why I mentioned, what if we're going decimal to decimal, which is base 10, which feels stupid, but you're going to see that it's the same pattern. That's why I'm having you do it. So 19 divided by 10. How many times does 10 go into 19? It goes in 1 time. 1 times 10 is 10 with a remainder of 9. How many times does 10 go into 1? 0 times. 0 times 10 is 0 with a remainder of 1. Read your answer from bottom up, you get a 19. So you see that the identical pattern works for converting a decimal number to the equivalent number in decimal. Okay. Right, so the algorithm for converting a decimal number to any base is to start with a decimal number, start dividing it by that base until you get a quotient of 0, and you record. In this case, we're displaying the remainders over and over and over again. Okay. So again, for the assignment for see, when do I want to have this due? I'll have this due before class starts on Tuesday when I'm back. So I'll make this assignment due by Tuesday, the, put it up here, due what is that, 10/17 by 10 a.m. Okay, so you have a week to do this assignment. It's not going to take you a week in terms of time. Hopefully you know, once you get past the intimidation of, oh my gosh, we're converting numbers between bases, that must be really difficult, and realize that, oh, I'm just writing a loop that keeps going until some number is 0, and I'm displaying to the screen the remainder over and over again, you're going to see pretty quick that this actually only is a couple of lines of code to write this. Okay. And that's part of what we're doing, though, is we're trying to remove some of that intimidation factor, because right now everything looks scary because everything feels like it's difficult. So hopefully you saw, when you saw the solution to today's homework, you saw that it actually wasn't very difficult, but you making that translation between what is he asking me to do into how do I explain to a computer the individual little steps necessary to do that, right? That's kind of the skill you're learning here. You're not learning C++. That's just as the syntax you're using, and you'll eventually figure out when you know what you're prone to in terms of forgetting semicolons or curly braces or all that jazz. You'll eventually figure that stuff out just from putting in the reps. Okay, right now you're training your brain to explain to a computer how to solve a problem. All right. So I will put this assignment up. Again, you are writing 3 separate functions here: decimal to binary, decimal to octal, decimal to decimal. But what I'm telling you is all 3 of those functions are the same function. The only thing that will change is, are you dividing by 2, by 8, or by 10? And notice I am purposely not having you do decimal to hexadecimal, because that would require you to look at the remainders. So for example, if we were to do a hexadecimal number, you might have remainders of 10 or 11 or 12, 13, 14, 15. You would then have to take those remainders and convert them into the equivalent letters. If it was a 10, you'd actually show an A. and 11 would actually be a B, so on and so forth. And we will look at that on Tuesday, because we're going to write another function that maps to the, maps the number to the correct letter. And then we're also going to be introducing arrays, the way that we can collect a whole bunch of answers and then reverse it. So if you want to look into some of that stuff, if you currently are feeling the stuff we're doing is comfortable for you, feel free. That's what we're going. That's where we're going. On Tuesday, we'll introduce arrays. We'll introduce, we'll write a function that does some conversion things. So if you want to challenge yourself or jump ahead a little bit, feel free. But most of you right now should feel fairly uncomfortable with this stuff. And I promise you, what I'm throwing at you is pretty easy, but it's not going to feel very easy for you at this point. But hopefully you're seeing that we're taking tiny little steps where we're doing the same things, but we're accomplishing more complex tasks. Okay, so again, it'll be due before class begins a week from today on Tuesday the 17th. So today you'll have Waleed again for more quantum stuff, and you'll also have him for Thursday, and then you'll have me again on, let's say, unfortunately or fortunately. But hopefully these lectures are helpful, and I'm giving you enough time to put the reps in for these things, so you're kind of getting extra value for your time. Okay, I will put the video up, I will put the assignment up, and I will see everybody in a week.